Dear students, welcome to the problem solving session on D'Alembert's ratio test, or people simply say it as ratio test. In the first video, we see the basics on sequence and series, what is convergent series, what is divergent series, and we go for the limit comparison test, and we did few problems in the two videos, part 1 and part 2. Those who don't watch the videos, go to the playlist, first watch limit comparison test, and then you can come for this session because this is the next level for the limit comparison test. What is limit comparison test? If you take a positive term series un and vn, if you find un by vn, limit n tends to infinity, you will get some finite value L. Very important, it should not be equal to 0. If it is not equal to 0, then if Vn converges, then Un also converges. If Vn diverges, then Un also diverges. So simply we say Un and Vn converge or diverge together. Suppose for example we have Un, n divided by n plus 1, n plus 2, n plus 3. So what we did, we take n outside because we are going to apply infinity. So n into 1 plus 1 by n into 1 plus 2 by n into 1 plus 3 by n. Then we try to cancel whatever it is possible and then we apply the limit. And the guys who are making trouble, we take the guys as Vn and then using limit comparison and the basic result, we solve the problem. Now, every method has its own drawback. Suppose if my nth term is 2 power n by n factorial. Now, how can I take n factorial outside and cancel it? Because n factorial, if I simplify, I can write n into n minus 1 factorial. Then n into n minus 1 into n minus 2 factorial. It goes on. Now I cannot take n outside and cancel. So, limit comparison test have some issues when the problem has n factorial. Similarly, if I have a term n plus 1 whole square, then I will take n outside and 1 plus n like this, and I can write like n square into 1 plus 1 by n whole square. But suppose if I have 2 power n plus 1, how can I take n in common? So n power any number or something like this, or n plus 1 power any number, I can simplify. But anything power n, I cannot use limit comparison test. So simply what we say, limit comparison test fails or it has a issue when we have a problem with n factorial, a power n power n, etc. Also, in limit comparison test, for example, we see the terms are fixed. Each term in the denominator, we have two data. Similarly, one data. We can go for many examples. But suppose if I have a problem like this, here you see the series is increasing. In first term, both numerator, denominator, I have only one data. In second term, I have two data. In third term, I have three data. In this case, I cannot apply limit comparison. So I just give four informations to you. When n factorial is there, a power n is there, n power n is there, or the terms are increasing, then limit comparison test is not much suitable. Then we are going for the new test. That is my higher level test. So every method has its advantage as well as drawbacks and limitations. So LCT have limitations in this four cases. So let us go to the next method. It is called as D'Alembert's ratio test. People simply say it as ratio test. Now we are going to take a positive term series un. So what is the idea behind it? Suppose my nth term 2 power n by n factorial. How can I remove this n factorial, or how can I cancel this n factorial? Because I cannot take n outside because it keep on going till 1. The great idea, if you take the n plus 1th term, it will become 2 power n plus 1, n plus 1 factorial. Now, this n plus 1 factorial can be rewritten as n plus 1 into n factorial. Now, if you perform un plus 1 divided by un, what will happen? This n factorial will get cancelled. So, in a easy way, I can solve these kind of problems. This is the idea behind D'Alembert's ratio test. So what they are going to do, you find nth term and find n plus 1th term, un plus 1 by un, limit n tends to infinity, we will be getting L. And important, in limit comparison, it should be finite and it should not be equal to 0. In ratio test, it should not be equal to 1. So if it is less than 1, summation un converges. If it is greater than 1, summation un diverges. If it is equal to 1, test fails. So D elements ratio test have a drawback. When you get L equal to 1, I cannot say any conclusion. Here the test fails. Hope you understand, students. With this idea, let us do some problems on D-element ratio test. Let us see an example. Discuss the convergence of 1 plus 2 power p by 2 factorial, 3 power p by 3 factorial, 4 power p by 4 factorial, etc. p greater than 0. So first step, as usual, I said, let us consider summation un is our question. This one is simply rewritten as 1 power p by 1 factorial. And here in ratio test, finding the nth term is going to be very easy. See the numerator, first term 1 power p, second term 2 power p, third term 3 power p. So 1 power p, 2 power p, 3 power p, etc. The nth term is going to be n power p. Simple, student. Similarly, when we come for denominator, first term 1 factorial, second data 2 factorial, third data 3 factorial, etc. So now my nth term in the denominator is going to be n factorial. So this is going to be very easy. So my nth term is n power p divided by n factorial. Next, I am going to write n plus 1. Simply replace n by n plus 1. So we'll be having n plus 1 whole power p divided by n plus 1 factorial. Now, since I am going to divide this 2, we have to simplify here. So n plus 1 factorial can be simplified as n plus 1 into n factorial. Here I can take this n outside, 1 plus 1 by n whole power p. Now let us divide un plus 1 by un. So when you divide, just write the reciprocal. Don't do like a school student. Just write this as it is, and un term you write in reciprocal. So I can simplify this also. I can write n power p 1 plus 1 by n whole power p. Now n factorial and n factorial get cancel. N power p and n power p get cancel. If you apply the n tends to infinity, since in the denominator I have n plus 1, immediately it becomes 1 by infinity, that is 0. But it is good. In ratio test, my L should not be equal to 1. Here it is 0, that is less than 1. That is good, no issues. Now, if it is less than 1, by ratio test, we can see it is convergent. Therefore, the given series is a convergent series. See how easy it is. So, if you have n factorial, n power n, a power n, or increasing terms, just use ratio test to solve the problem in a simpler way. Hope you understand.
Thanks for watching. Subscribe to our channel and share to your friends. See you in the next video. Bye bye.